All right. Hello, everybody. My name is Derek Demeter. I'm the Planetarium Director of the Emil Buehler Planetarium. And tonight we have Justin Cirillo. He is my, right-hand man, the planetarium specialist, the man that is really into space exploration. And he is going to be sharing you all a really interesting program about the final frontier, exploring human space, space flight, and kind of looking at the past, present, and of course the future of human space flight. And so what I'm going to do now is I'm going to go ahead and give Justin the ability to co-host. And what I'm going to do tonight is I'm going to go ahead and play the role of answering your questions, things like that tonight. For those that are watching on the Facebook Live, what we'll do is we'll hold off the majority of the questions till the end. However, if there's a particular question you want or something you need readdressed throughout the program, just let us know. Otherwise, I'm going to go ahead and give it over to Justin. And with that, enjoy the program tonight. And Justin, let's get started.
All right, excellent. Well, I hope everyone's having a good night tonight. We are burning through these things. We were just talking about what episode are we on here? 6 of our
I think yeah, it is episode,
public series. Yeah. Yep. And then tomorrow night we've got episode 6 of Virtual Star Party. So
right.
Man, we have been there's no break for us when it comes to a pandemic. We keep giving you science. What have you been doing to keep busy during all this craziness besides all work, Derek? Anything fun?
Well, obviously, my wife and I have been enjoying the great outdoors. That's a really nice way to enjoy social distancing while also getting outside. It's also been proven that getting exposure to the sun helps with your immune system. So, and obviously breathing in the fresh air. So we've been doing biking, kayaking, things that obviously try to get away from most people. But of course, also as an astronomer, I still have been able to go out to some of my dark sky locations and being able to take some photos of the night sky. Again, those are in pretty remote areas of the state. So again, very, very pretty much away from everybody. One of the locations I've actually gone to is in a county where there's been 1 case of coronavirus. So again, very low risk. I take it very seriously, but at the same time, I know that there are things you can still do that can give some enjoyment during this time while also maintaining social distance. What about you, Justin? What have you been doing?
Yeah, it's definitely been an adjustment, right? You and I, our entire job evolves around being around people and being around
Right.
kids and groups and outreach meetings. So going from that, when we had a pretty busy spring planned of shows, and luckily a lot of those shows we were able to convert from a physical field trip to a virtual field trip. So I feel pretty good about that. But yeah, just I've been catching up on a lot of things around the house. I've been getting a lot of exercise. I've been, my wife and I go on hikes every day at lunchtime. So we're making do and getting through it. And
it will be nice to see you again in real life. I feel like it's been weird.
Not the digital you.
Yeah, not the digital me. I mean, it's all good though. But you know what? We are very fortunate, as Justin said, to be able to continue doing what we do and trying to be proactive and trying to be innovative and utilize some of the technology that's available to give you all a chance to escape planet Earth for a brief moment in time, to just, remind ourselves that, we can still enjoy the beauty of the universe, even in such a horrible time that we're dealing with right now. So we really appreciate all of you that are tuning in and enjoying these programs. And we plan to do them for a while now. I know there's talks about potentially reopening, probably within a few months or so, but we're obviously going to be monitoring in that. But of course, we're going to continue doing these until we feel that it's comfortable to to bring as many people back. But we're not going to stop. We're going to continue these, and we're really appreciative of all of you tuning in.
And wait till we show them Space Engine.
Woo! I know, right? Yeah, we got some really exciting software that we just downloaded both Justin and I have been playing around with that, and we are hoping to show you some of that cool technology. And the best part, too, is that this technology is also integrated into Planetarium Dome. So actually, when we reopen again, we'll be able to show you some of this really cool software on the dome. So it really expands some of the things that we can do, for sure.
Absolutely. All right. Well, let's jump right into this, right?
All right, let's do it.
Yeah. So this show tonight is called The Final Frontier, and what we wanted to kind of do with this show was give you kind of the history of space flight. What's been going on over the past, 80, 90 years, and what are we doing now, and where are we going? So tonight we're going to kind of take an 80-year journey through the history of powered flight and discuss where we're going. There was a pretty big announcement today. Some of you may have seen that. We'll talk about that a little bit later in the show. So let's start off with Flyer 1. We're at stardate December 17th, 1903, and the Wright brothers have just flown Flyer 1. This was designed and built by the Wright brothers, of course, just north of Kitty Hawk, North Carolina, and they were the first to achieve controlled, sustained flight with a pilot aboard. Well, within one human lifetime, we go from first flight to landing on the moon, less than 70 years. What an incredible achievement. Imagine living through this time period where you go from anything before flight to watching us land on the moon. Just an incredible display of engineering and ingenuity over, a relatively short period of time. Well, what we're going to talk about now is what kind of went on between that time period to get us from 1903 to 1969. Now, space travel was born from war. This is the German V2 rocket, and on June 20th, 1944, it crosses the Kármán line. And this is about 62 miles above the Earth. And this was the first artificial object to travel into space. Prior to its space flight, it was the first short-range guided ballistic missile developed by the SS German Army. And an engineer named Wernher von Braun, who would later go on to design the Saturn V rocket with NASA. Now, unfortunately, space flight, it does have very dark beginnings. The attacks of the V2s, they resulted in the deaths of 9,000 civilians, military targets in Europe. Another 12,000 laborers would die as a result of forced participation in building these weapons. So spaceflight begins with a very dark history. But Wernher von Braun, even though he was involved in war, his main priority was not building weapons, advancing Germany. He had a vision of going to space, and we're going to talk a little bit more about his influence in the United States space program. But this is an image of Peenemünde, and this is where a lot of the research and development, a lot of the test flights occurred by the German Army. And actually, Derek, you were there, just last summer. You want to tell us a little bit about your visit there?
Yes, so we do this show at the Planetarium, and during that program, we have the ability to show you kind of the location. But yeah, Peenemünde was quite an interesting experience to be there in Ground Zero, the first place where they tested these V2. They also tested a V1 rockets, and it was really crazy to see that this was the place. But one of the most interesting, Justin, I'm not sure if you talk about this, but we also got a chance to go to the Middelbrow Dora concentration camp, where they actually continued to research once Peenemünde was destroyed by the Allied forces. And it's just crazy to think that this is all where it started. And Justin's right. Werner von Braun, he was not, even though he was part of the Nazi regime, he really was only part of it because he knew that the powers at the time, you know, that was the only way for him to get the funding to do his research. You know, so people like to say that, oh, you know, Werner von Braun was a Nazi, but in reality, he was just playing the act in order to get the ability to develop these rockets. So when he finally, so it's really cool to see all that history. There's a really nice gallery museum there that kind of talks about all that there.
Excellent. Well, you had some very high-profile operations by both the United States government and the Soviet Union at the time. So we're 1946 here. We've got Operation Paperclip. We've got Operation Ozov-Avakim, and these were both of these major powers. Germany was crumbling. You've got the United States now scrambling to grab these German scientists. We were fully aware of the technology that they had created, and the Soviet Union was doing the same thing. Soviet Union was very aggressive, and they kind of forcibly recruited over 2,000 German specialists and took them back to the Soviet Union to begin work on what would become the Cold War. Von Braun and several other German scientists surrendered to the United States, and he felt he had a better opportunity in the United States to have more freedom to develop what he wanted. His personal agenda was, of course, space. So they were transferred to Redstone Arsenal in Huntsville, Alabama, and that's where the whole process started. You can see a picture of von Braun there. He's centered at the center of the table there with some NASA administrators. You can see a picture of him in the upper right corner here with some of the technology that he put together. And he was really the primary architect for the Saturn V rocket, which you can see behind me here, my Lego version of it, and that would take us to the moon. So we'll get to that shortly as we get into the 60s. Well, just about, oh gosh, a year later, 1947 now, October 14th, 1947, Chuck Yeager, he made history, and using the Bell X-1, this was kind of a essentially a rocket engine powered spacecraft. You can actually see this at the Smithsonian Air and Space Museum. It's hanging there. Past Mach 1. It was dropped from a B-29 airplane, 42,000 feet. He was going about 0.98 Mach, and as soon as he hit 43,000 feet, his Mach meter jumped off the chart, and I think he hit something like 767 miles per hour. So this was a major milestone in spaceflight, and you can see he named his rocket there Glamorous Glennis after his wife, and just a major milestone in spaceflight that would kind of pave the way to our next era. And when we're going through these, really keep in mind that these men, these pilots, were they were test pilots for the engineering that was being developed at the time. So just an incredible amount of bravery, of guts to be able to push the limit on all of this new development that was taking place at the time. Well, remember those 2,000 Soviet scientists that they took, that Soviet Union took? Well, within 10 years, on October 4th, 1957, Sputnik is put into space. And the Soviet Union would just make incredible progress in that past decade to put Sputnik in an elliptical low Earth orbit. And it orbited for about 3 weeks before its batteries died, and then kind of silently for another 2 months before it fell back into the atmosphere. But imagine you've got a ham radio, it's the Cold War, and you can pick up the signal of this Soviet satellite, your enemy that wants to put uh, a weapon in your backyard. And how frightening would it be to pick that up, to hear that above your head? And this really woke up the United States, that they were falling behind in this space race and really needed to pick up the pace. And that is exactly what they did. But it would still take a few more pretty amazing milestones by the Soviet Union. The next one on the list, we just had an anniversary for it, April 12th, 1961. Yuri Gagarin and Vostok 1. The Soviet Union again would make an incredible first milestone. Vostok 1 was the first space flight of the Vostok program and the first crewed space flight in history. The Vostok space capsule was launched from Baikonur Cosmodrome. That would be kind of our version of Cape Canaveral. And Yuri Gagarin was on board. And this made him the first human to cross into outer space. And his space flight was short. It was a single orbit around the Earth, kind of skimmed the upper atmosphere. I think he was about 91 nautical miles above the Earth, kind of at its lowest point. And his flight took about 108 minutes from launch to landing. But think about that ride. Think about the bravery of this guy. He gets on a rocket that was probably blowing up over the past few years in testing, gets on this rocket, he launches into space, orbits around the Earth one time, and then falls back to Earth, ejects from his capsule at 23,000 feet, and he parachutes to the ground. I mean, talk about a ride. Well, he becomes a national hero and instantly worldwide celebrity. And I hear he's a pretty good hockey goaltender too, but he didn't do much flying after that. He was kind of a national treasure, and so they didn't want to risk losing him. And he helped with some of the future programs that we're going to talk about here in a little bit. But just an amazing feat for this man, and we celebrate him on every April 12th for Yuri's Night. Well, unfortunately, there are casualties in spaceflight also. It is not always these incredible achievements, and many casualties before pilots would ever get into space would be animals. And you remember, these guys are test pilots. Their job was to push the boundaries of engineering faster, higher, but there were animals in the mix too. This is Laika, and Laika was a Soviet space dog, one of the first animals in space, first animal to orbit the Earth. Laika, it's 1957 in this picture, so we're about 4 years before Yuri Gagarin would go into space. This stray taken off the streets in Moscow and was the occupant of Sputnik 2. And Laika died within a few hours after launch from overheating. Wouldn't be the last animal to go into space. In the 90s, the US would send, many different animals on the space shuttles. Crickets, mice, rats, frogs, jellyfish would all go up into space. But animals also sacrifice themselves for our progress. April 24th, 1967, Vladimir Komarov. This guy had a tough day. His one-day mission was just plagued by a series of mishaps. They were working on a new spacecraft type at the time, the Soviet Union was, and his parachute did not open properly after it came through atmospheric reentry. So he hit the ground at full speed. He was obviously killed when the capsule hit the ground. So this was a big setback for the Soviet Union. 1971, we have the crew of Soyuz 11. And this is actually the backup crew. The primary crew was scheduled to go up a few days before. One of the members of the crew had tested positive for tuberculosis, and so this backup crew was assigned to the mission. And they were on the Salyut space station for about 3 weeks, and on their way home, there was a valve defect that caused that when they were separating from that service module that caused them to be exposed to space. So when people ask how many people have died in space, these are the only 3 to have ever died in space. We've lost a lot of people, inside the Earth's atmosphere, on the ground in testing, space flight on the Earth. But these 3 men were the only ones to die in space. They unfortunately suffocated inside the capsule when they came into Earth in re-entry. When the capsule landed, the recovery team opened up and they found the crew was dead. So just another big setback for the Soviet Union. Well, the United States of America, NASA, they had troubles of their own. Right now we're at 1957, and what you're seeing here is Vanguard, and it was the first attempt by the United States to launch anything into orbit around the Earth. Well, it didn't go very well, and this was kind of a major embarrassment at the beginning for the United States, because they were well behind the Soviet Union at first. They would catch up, as we all know the story, but they were pretty far behind initially. Well, May 5th, 1961. This wasn't much longer after Yuri Gagarin would go into space. Alan Shepard becomes the second person, the first American, to travel into space. And it was the first crewed flight of Project Mercury. And Shepard named his spacecraft Freedom 7. It was launched on a Redstone rocket. On the stamp there, you can see the Freedom 7 capsule that he sat in there on his left shoulder, and then over his right shoulder is the Redstone rocket. And again, just imagine the bravery of these guys. They're sitting on top of a rocket that, again, this is essentially an ICBM. The faith these guys had in the program was just amazing. And well, Shepard's famous quote was, a reporter had asked him, and they said, "What did you think about when you're sitting on top of this Redstone rocket, waiting for liftoff?" And he says, "Well, I'm sitting there thinking that the fact that every part of the ship was built by the lowest bidder." But he goes up. It was a short flight. I think it was only about 15 minutes. He wasn't like Yuri Gagarin, where he went up, orbited the Earth, and came back down. He literally just went straight up and came straight back down. But it wouldn't be long before we put an American in orbit around the Earth, and that would be John Glenn. He was the first American to orbit the Earth. He circled it 3 times in 1962. And then right behind that, just a few years later, we began seeing EVAs. EVAs were extravehicular activity. This is when the astronaut would actually leave the spacecraft while it was orbiting Earth and get the opportunity to move around outside the capsule. This particular first event was by the Soviet Union, and this was cosmonaut Alexei Leonov. And he spent about 12 minutes orbiting his spacecraft. He had a white metal backpack that had about 45 minutes worth of oxygen, but he didn't have any means to move around. He just had a tether, a 50-foot tether that held him to the hull. So what a ride and what a view that must have been, right? Alexei Leonov was part of that primary crew of that spacecraft where the 3 Soviet Union astronauts died. So his crewmate had the tuberculosis. He did not get on that spacecraft and therefore did not perish in that flight. He becomes the first human to do an EVA in orbit of Earth. Well, then we've got our first American spacewalk was Ed White, and he orbited the Earth about 3 months later. I think it was June. It was that summer of 1965, and he was on the second crewed Gemini flight. He was up there he was outside of the spacecraft for about 20 minutes, and he was also tethered. He had his oxygen supplied through an umbilical, and he had a cool little handheld maneuvering unit that had about 20 seconds worth of propellant. So he could kind of shoot himself all around this thing, and he was having so much fun. Mission Control had to literally order him back into the spacecraft. He would not come in. You've got to watch this video sometime. It's just hilarious to watch how happy, excited, incredible that experience must have been. And sadly, Ed White, he would die 2 years later. He was in the Apollo 1 command module fire during testing, along with Gus Grissom. Gus Grissom was the third American in space, and Roger Chaffee. So those three men would perish just a couple of years later. But you can see how tight-knit this community was of astronauts that were just doing these incredibly amazing feats, but it just reminds you of how dangerous they were at the same time. Well, now we get to Apollo. We have the Mercury program that's put a human in space. We have the Gemini program let's learn how to work in orbit around the Earth. And then we have the Apollo program, which is let's put a human being on the moon and get them safely home. That was part of the directive. And, the all-star of the Apollo program was the Saturn V rocket. This rocket was just a beast. It was 6.5 million pounds. It had 7.7 million pounds of thrust. This thing was powerful enough to go to Mars. And this is back in the 60s. I mean, we had this technology. Wernher von Braun, his ultimate goal was to go to Mars. He had already put together extensive plans to go to Mars back in the late 50s and early 60s. So he always had this agenda in the back of his head that, want to push, want to go further, want to go faster. And that's why we had such a beast of a rocket to get us to the moon. Of all the amazing achievements of Apollo, one of them I think stands out for me personally was the transposition, the docking, and the extraction of the LEM. The Saturn V rocket was in multiple stages, and the first two stages were mainly propellant. This was just to get you off of Earth. And once you were done with those, you had a third stage, and that third stage contained the command module, the service module, and the lunar module. Extracting the lunar module from the booster was just an amazing achievement, and it typically took about 90 minutes to complete, but I found this clip that describes it better than me trying to articulate how it works, shortened into about 30 seconds. But check this out. Fairings open, the command and service module come out, they speed up a little bit, they slow down, they spin it around 180 degrees, and they connect it to the lunar module and extract it out of the booster. Just incredible achievement. And a lot of people have never really seen this level of detail that came with this achievement of going to the moon. I'll show it one more time. Keep an eye on all the different thrusters that are going on the command module, service module, while this is taking place. The way that they were able to maneuver it, set it up, dock it, and extract it. Just, you could watch this 100 times. So cool. Well, then we get to the moon, and we're all pretty familiar with that, right? The Eagle landed on Sunday, July 20th, 1969. And it was a pretty exciting landing. Had all sorts of alarms going off. The computer was getting overloaded with so much information coming in from the surface of the moon. You've got Neil Armstrong and Buzz inside the LEM. They're trying to set down in an area that they thought was good for landing. And by the time Neil sees this area that they're supposed to land in, he's going, there's no way we're landing here. So he had to quickly kind of take control of the LEM, and he wasn't in full manual mode. He was kind of a hybrid mode of the computer and him controlling it. But they were eventually able to touch down in a safe spot. That LEM had enough fuel for something like 50 seconds of powered flight before an abort without touchdown would have become unsafe. So when you watch the video, it shows about 11 seconds before they would have had to abort. So just incredible timing to get that down where they needed to be. Their EVA was about 2.5 hours. And meanwhile, Michael Collins, he's still orbiting the moon right now. He's up in the command and service module, orbiting the moon. They talk about him being the loneliest guy in the universe at this point in time. Imagine up there all by himself. And Neil and Buzz get to go down on the surface. They grab about 50 pounds of lunar regolith to bring back to Earth, set up a couple experiments, and then, well, just like The Martian, if you guys saw The Martian, right? This LEM was in two parts. You see the kind of gold foil bottom piece, and then that top piece was literally a moon rocket, and it would detach from the bottom of the LEM, fire up, reconnect with the command and service module as it was going around the moon, just like Watney did, without the exciting, Iron Man cut a hole in your spacesuit and catch up with this. But that's Hollywood. But very similar, right? Launch off the moon, connect with the command and service module that's orbiting the moon before heading back to Earth. Just an incredible achievement, right? And there were 9 additional Apollo missions planned. 5 more would go to the moon. 6 if you count Apollo 13, but 13 had the explosion in the oxygen tank as it was heading to the moon. So they ended up just kind of whipping around the moon and heading back to Earth and safely getting home. 16 and 17, Apollo 16 and 17 had those cool lunar rovers. So you see all those videos of them driving around on the lunar surface. Those were the last 2 Apollo missions had that amazing tool so that they could, they did a lot of geology work on those last few missions.
Hey, Justin?
Yeah.
We have a question. Somebody asked what regolith is. What is regolith?
Oh, regolith. Okay, regolith is just another name for soil, in a sense. You hear us talk about regolith a lot when it comes to the moon, Mars, asteroids. Regolith is the surface material on that body. Very good question. Well, Derek, imagine this. Apollo 18 was scheduled to land in the Copernicus crater. Apollo 20 was scheduled to land in the Tycho crater. I mean, these, for an astronomers, we drool over looking at these. We've been showing these to people for, as long as we've been looking through telescopes. I mean, Derek, can you imagine if, we had actually gotten a chance to do that and the visuals that would have come back from that? Just absolutely amazing.
I couldn't imagine. It would be incredible.
I know. But those programs were canceled. We're in 1972 at this point, and at this point in time, the Apollo program had reached about $25 billion. We're 1972, $25 billion into this, and while we discovered and learned just an incredible amount of science, that's a lot of money. And NASA was already working on the next projects. We still have Skylab that needs to go up into space that they were working on. They had already started putting plans together for the space shuttle. So, it's just nonstop. And as much information that we got from those moon missions, there wasn't any real compelling reason to go back? Well, not yet. We're going to find that compelling reason later in the show. It's there. We didn't find it yet. So that is our Apollo mission, and just an incredible achievement by the United States of America. 500 million people tuned in to watch that first landing. Well, then we get to Skylab, and this is the first space station launched by NASA. And it was went up in May of 1973, just a few months before I was born, and it was up for about 9 months. Well, it was occupied for about 9 months. It was orbited the Earth for several years, but for about 9 months, it was occupied by 3 different crews that, gosh, they did all sorts of amazing science. It was an orbital workshop, solar observatory. They did tons of Earth observation from it, and just hundreds of experiments. But the way it was built, it didn't have the capability that the International Space Station had for boosting itself back up into a higher orbit. So Skylab, after those 9 months of science, it was no longer safe to occupy the space station, and it would eventually drop into the Earth's atmosphere, decay into the Indian Ocean in 1979. But it was a short program. It was a short engineering achievement, but it gave us a ton of science knowledge that would take us where we needed to go next, which was build the next generation of space station. Well, then we get to a couple of my favorite spacecraft. Stardate, August 20th, 1977, Voyager 2 launches. And September 5th, 1977, Voyager 1 launches. And this confused the media. They're like, why is Voyager 2 launching before Voyager 1? What's going on here? And well, Voyager 1 would eventually overtake Voyager 2, but that's why they went up in that order. But these were the first spacecraft to really do a detailed survey of the outer planets. Voyager 1, Voyager 2, there were 2 of them built for redundancy in case for some reason one of them didn't work, it was destroyed in its mission, anything like that. That's why they built both. And their mission was to explore the outer planets, visit Jupiter, visit Saturn, visit Uranus, and visit Neptune. Now, this concept of this grand tour, it started back in 1964. A scientist named Gary Flandreau, who was he was actually born in Salt Lake City, my hometown. He worked for a JPL, Jet Propulsion Laboratory in California. And when he was working on a project, he kind of realized that an alignment of Jupiter, Saturn, Uranus, and Neptune would occur in the late 70s, 15 years into the future, that would enable a single spacecraft to visit all of these planets by using a gravity assist from each one. So Voyager 1 and 2 could fly to Jupiter, use its gravity to slingshot itself to Saturn, use Saturn to slingshot itself to Uranus and Neptune, and so on. So what an incredible opportunity. And this particular alignment, it only happens once every 175 years. So when they proposed the project idea to Richard Nixon, the running joke at JPL was the last president to have this opportunity was Thomas Jefferson, and he blew it. So you've got to do this. So by mid-60s, JPL was, promoting the project, saying that, this would allow a complete survey of all of these outer planets in less time, less money than sending, an individual probe to each planet. So amazing opportunity. It got the green light. They built them, and off they go. On each one of these was a golden record, and this was kind of inspired by, I think, both Derek and I's favorite astronomer, Carl Sagan. He was the architect of the record's contents These were kind of similar to the plates that were on Pioneer 10 and 11. I don't think 10 and 11 were records though, right? I think they were just plates with instructions on where these spacecraft came from. But essentially, if one of the Voyager spacecraft were discovered in 1,000 years, 10,000 years, and 1,000,000 years, whoever found them would find greetings in numerous languages from Earth, photographs, something like 25 or more pieces of music. The only kind of popular music was Chuck Berry's Johnny B. Good. And the Beatles apparently failed to make the cut because of licensing issues. Imagine that. You have a chance to put your music on a spacecraft that goes interstellar and could be picked up by an alien civilization, and it doesn't happen because of licensing issues. But Mission Control's in-joke was centuries later, NASA finally receive a message from aliens, and the message says, "Send more Chuck Berry." But these spacecraft, they're 13 billion miles now from the sun. They're traveling at 38,000 miles per hour. Each one of those slingshots sped them up even further, and well, there's nothing there to slow them down, so they're just flying through space. About half the systems work on each one. They had about a dozen instruments, and NASA still talks to them. They're, I think, 20-hour light minutes is how long it takes. So if we want to send a message to Voyager, it takes about 20 hours for it to receive it, and then 20 hours to get that message back. And that, of course, is going to continue to lengthen as they get further and further out into interstellar medium. And these guys, you notice there's no solar panels on them. I don't think at this point the sun would have even helped. These are all powered by RTGs, radioisotope thermoelectric generators, and they're still working. So these were built in the mid-70s. It's now 2020, and they are still going. If you want to track the status of the missions, I put a link there at the bottom of the page, and you can go to that website, and it shows you their distance and things like that. A very cool way to track their progress. Well, then we reach the shuttle missions. We're at April 12th, 1981. Does that date ring a bell to anyone? Sound familiar? STS-1. STS stands for Space Transportation System. This launch occurred on the 20th anniversary of Yuri Gagarin's first spaceflight. And it was actually a coincidence because they were supposed to launch 2 days earlier. There was a technical problem they had to work out, and so it ended up going up on the 12th. But pretty cool that they share that same date of April 12th. The space shuttle was a brand new technology for NASA, a glider that would be taken up into space, be able to do science, and then travel home just like an airplane in a sense, glide home. And the first orbiter was Columbia, and I don't know why I didn't put a picture of Columbia here. I've got Discovery and Atlantis, but Columbia was the first orbiter, and it was up in space for about 2 days. It, I think, orbited the Earth about 36 times in that time frame that it was up there, and it just had a crew of 2. A lot of people think of the crew of 7 that would generally be on the shuttle, but just had John Young, a local Florida astronaut, and Bob Crippen were on that first inaugural flight. But the space shuttles would be monumental for NASA in being able to shuttle, I didn't even do that on purpose, hundreds of satellites into orbit, military satellites, communication satellites, different spacecraft, the Hubble Space Telescope, and they would be the key component in taking all the modules up to build the International Space Station. And the first launch I saw live was here in Florida. I didn't move to Florida until 2005. I think that summer I'll get into a little bit more after Columbia. After Columbia, the shuttle program was shut down for 2.5 years. But just after that, once the shuttle started flying again, that's one of my most vivid memories, is being at lunch with a coworker and watching the shuttle launch. I was in Maitland at the time, and it's 60 miles away, and just watching the sight of this incredible launch going up, and I was just blown away. And they're like, yeah, that happens all the time. It's not that big a deal. But for me, man, it changed my life. After that point, I was hooked. Well, the final flight of the shuttle program was July 8th, 2011. And that was the last time that American astronauts would go into space from American soil. 2011 was the last time. And over the next almost decade, we would pay the Soviet Union, or Russia, I shouldn't have known the Soviet Union anymore, Russia, to launch our astronauts up into space. Well, that's going to change next month. Well, we get to the International Space Station, and this was a 20-year project beginning 1977. This spacecraft took 20 years to build. It's essentially an artificial satellite in low Earth orbit. It's about 245 miles above the Earth, and it's falling around the Earth at 17,500 miles per hour. You can go outside and watch it pass over your head if you're in the right place at the right time. Get one of those cool apps that tells you when it's going to go over, or go to the ISS website. It'll tell you when it's going to pass over you. But yeah, it's falling, and those astronauts that you see on board that are floating, well, they're still in Earth's gravity, but they're in a constant state of free fall, and that is why you see them doing all the cool things that they do. The ISS, it has a maintained orbit because it goes through a kind of a series of reboost maneuvers. It has onboard engines that, as it slowly drops down into a lower orbit, those engines can push it back up to where it needs to be, and it has to do this on a continual basis. But this thing is huge. It is the size of a football field. It's called the International Space Station because it's a joint project between 5 participating space agencies: NASA, Russia, Japan, Europe, Canada. There's probably even a couple more in there that I didn't mention. But this space station, it has really been the thing that has given us the ability to understand how humans react to microgravity. We've been wanting to send humans to these far off distances in the solar system, throughout the galaxy, reliving all of these stories of pop culture and sci-fi. But the space station taught us that our bodies, well, they work well with gravity. And this is where we learned that what happens to the body when we spend large amounts of time in microgravity. Scott Kelly spent a year in space, all kinds of issues, changed his DNA. But one of the most significant is the loss of bone and muscle mass. These are things that we didn't realize back in the 60s and in the 70s. We needed a space station like this to learn these things, to learn the science. How does the human body react to microgravity? And we're still learning more about how this works. And this is going to be critical if we're going to take long journeys. It took 3 days to get to the moon and 3 days to get home. But if we're going to take journeys to Mars with humans on board, we're talking about 9 months one way. Mars has much less gravity than Earth, so we've got to deal with that. And then 9 months to get home. How is the human body going to react to potentially 4 years in an environment that it's not, designed for? So this is a big challenge, because we can send rockets and spacecraft and robots anywhere we want, right? They're low maintenance. Humans are very high maintenance. We need sleep, and we need vitamins, we need food, we need water. And that is going to be really the biggest challenge in getting us any further. But the space station has just been a massive accomplishment. It is the most expensive single item that has ever been constructed in the history of mankind. It's a $150 billion project. And a lot of the other countries pitched in on that price tag, but the majority of that did come from NASA. So the space station still going strong. NASA is even talking about allowing non-astronauts to visit the space station. You can maybe a couple years from now, you'll be able to jump on a SpaceX rocket and dock with the space station for just a cool $30,000 a day. But you have to stay for a month, so that's where it gets pretty pricey. Well, space is hard, and during the ascent phase of Challenger, we hit a major setback, a major disaster. On January 28th, 1986, we've got a crew of 7 astronauts aboard Challenger. During the ascent phase, about 70 seconds after liftoff, catastrophic structural failure. The entire crew, the entire vehicle is lost. And an investigation called the Rogers Commission, they later determined that the accident was due to failure of O-ring seals on the solid rocket boosters. And when these O-ring seals failed, it kind of created this flamethrower-like flare that essentially melted the struts, holding all of this together. And so everything started pivoting and exploding, and it was just a horrible, horrible day. The space shuttle flights were suspended for 2.5 years after that, while NASA worked out how to address all those hazards. The toughest part about this mission was you had a civilian on board, Krista McAuliffe. She's there. I don't know if you guys can see my cursor or not, but kind of third in from the left. And she was a teacher that was part of Ronald Reagan's teaching program, teaching kids about science. And so where normally you wouldn't have a lot of people watching this launch, millions of school children around the United States of America were watching this live. I was one of them. I was 13 at the time. So what is that, 5th grade? Watching this explosion on live TV and just trying to understand what we just saw. Even the teacher wasn't even really able to, give us a way of any type of closure on what happened. It was supposed to be an exciting, glamorous day and ends in just an absolute disaster. So that was really my earliest memory of watching a flight on TV and seeing that horrible tragedy develop. But we push forward, right? We move forward, and that's exactly what we did. And one of the questions I get asked a lot at the planetarium, usually people will pull me aside after a show, or a parent or even a teacher sometimes, and they'll say, we went to the moon 50 years ago. What have we been doing since then? Has anything been going on? And it was really hard to put this show together because I could go on for hours. I literally had to pare this down to just some of the monumental things that were important, I felt, to the audience and to me. But just look at all of the space vehicles. This isn't even the whole comprehensive list, of course, but all the places we've been around the sun, the planets, moons, asteroids, comets. Yes, we have not put any humans out past the International Space Station and out past the moon. And I talked a little bit about why with microgravity, but we have been busy, incredibly busy. And the amount of science that we have learned and brought back would just fill libraries with what we've learned over the past 50, 60 years. These are just some of the highlights that I felt would be good to show in this program. This image is the surface of Venus. And this was taken by Venera 13, a lander that parachuted to the surface in 1982. Venus's clouds are sulfuric acid droplets. And its surface temperature is over 900 degrees, hot enough to melt lead. And the surface pressure is the equivalent of being under 3,000 feet of water. And despite all this, Venera 13, was able to survive long enough to send back a series of images, which is the composite you see here, and perform an analysis of the soil. So part of the lander itself is visible in the lower right-hand corner. You can kind of see it there in the image, but just an incredible achievement to capture this image. They didn't mean to get the camera looking straight down at the ground. I'm sure they would have loved a beautiful horizon and landscape photo, but this is what we got. Solid ice discovery on the lunar poles. Our moon, you're looking at the South Pole on the left, the North Pole on the right. Those blue dots you see, if you could guess what they are, you're probably right. They're water, frozen water deposits on the lunar surface. This was a game changer. This is what helped us realize that we need to go back to the moon. We have a fuel source now. Rockets inside their boosters are liquid hydrogen, liquid oxygen, the same elements that are on the moon. We can now use the moon as a lunar gateway to take us to other areas of the solar system. Fuel for our rockets, fuel for humans. The Lunar Reconnaissance Orbiter has been doing science on the lunar surface for the past 10 years, bringing back incredible science. These are images of Comet 67P, and the European Space Agency took a spacecraft to orbit around this comet and actually put a lander on there too, a Philae, a small lander. Derek, can you say the name of this comet? It's got that long name, and I never remember. Do you remember? It's something like Churyumov-Gerasimenko, something like that. But
pretty close, yeah.
I always call it 67P because 67 is my hockey number.
That's fine. No,
yeah. But look at this. I mean, look at this. We're able to bring back images of this volatile surface of a comet. This is a moon around Saturn. These are ice geysers. If you look real close at the south there, ice geysers on Saturn's moon Enceladus. The Cassini spacecraft brought back these images. You're looking at ice geysers ejecting from a moon that's orbiting Saturn. And the Huygens probe, this is another moon of Saturn's called Titan. And the Huygens probe flew through this thick atmosphere of Titan down to the surface, found rivers and lakes of liquid methane. Look at those rocks, shaped just like pebbles you would find in a stream behind your house. These are just a handful of amazing discoveries that we've made over the past couple decades. Well, in 2003, we would have another setback, another accident, the final flight of Columbia, February 1st, 2003. And this one was a tough one. During the launch of this mission, a piece of foam insulation had broken off of the external tank, and it struck the wing of the orbiter. And this had happened before, but this one was obviously much worse. This foam shielding protects the orbiter as it comes through the atmosphere. It's essentially the heat shield. And they were able to show, they had onboard cameras that actually showed this foam hitting and the damage happening on the shielding. NASA knew that this was serious. The astronauts were still doing their mission up in space, but they knew that there was a very serious issue going on here with the orbiter. And before reentry, NASA managers had kind of limited the investigation. They did this because there was no way to fix it. There was no way for the crew to have fixed the problem if it had been confirmed. And so when Columbia re-entered the atmosphere, the damage allowed the hot atmospheric gases to penetrate the heat shield, and it destroyed the wing structure. It completely broke apart on re-entry. I remember this pretty visibly. Also, I was with a friend of mine rock climbing in the desert of California, and my wife had called me, and she's kind of hysterical. And you know, the space shuttle, it broke up on reentry, and I look up, and that's exactly what I see, are this debris field falling back down to Earth. So just a horrible, horrible day, and we would lose all 7 astronauts. Again, the program is grounded for another 2.5 years until NASA can work out the issues. But we keep moving forward. We keep moving forward, and one of the most incredible achievements that I think I have ever seen was the landing of the Curiosity rover on Mars. What you're seeing here is just a short video that JPL had put together, and the spacecraft had traveled from Earth to Mars. It's been traveling for about 3 months, and it's coming into the atmosphere of Mars now. This is called the 7 minutes of terror. 7 minutes of terror. Here's a quote from one of the engineers. "We've got literally 7 minutes to go from the top of the atmosphere to the surface of Mars, going about 13,000 miles per hour. I've got to do this in perfect sequence, perfect choreography, perfect timing. And the computer has to do it all by itself. There's no help from the ground, no help at all. If any one thing in that choreography doesn't work just right, it's game over." Imagine you're standing on the surface of Mars. You see this parachute coming down. You look up and you see this coming down to the surface. Ladies and gentlemen, we are the aliens. The engineering feat to do this is mind-boggling. The mathematics, the choreography, the engineering. The way they did it was they kind of settled on this rocket-powered sky crane, and it lowered Curiosity to the surface on cables. Once it touched down, it crash landed on a safe distance away. But watch this. Absolutely unbelievable. And this is going to happen again this summer. Perseverance, the next rover, is going to be launching from Florida here this summer, and will be landing in February of next year. This is Curiosity. Curiosity is a car-sized rover, and it landed in the Gale crater. And it's essentially a kind of a drone science laboratory. And Derek, I'll give you a chance to kind of explain to everyone what they're seeing here. What's Curiosity doing?
So Curiosity is in an area known as Gale Crater, which is an ancient seabed, about 3.5 billion years of exposed rock found in this area. And what Curiosity is interested in looking at is for evidence of ancient water deposits. So looking at clay deposits and other erosion layers, where Curiosity can analyze it and figure out kind of the geology and history of the planet Mars. And during its time, Curiosity has been able to discover some pretty cool scientific breakthroughs in Martian history. You know that Mars had a lot of water, a lot of liquid water, and oceans and rivers and lakes, and had all the ingredients geologically for the presence of water. So that is kind of the biggest thing. And so what it's doing here is it's able to drill the rock material, bring it into its housing, and do different types of tests and look at various different areas, chemistry of the rocks, to understand what's in it, the chemicals that are found in the rocks. So it's a chemistry lab, it's a geological lab, it's a rock hounder, it's a chemistry lab, it's an explorer. So some really cool things. If I was a robot, I would probably be Curiosity, being able to do some rock exploration on the Mars.
Just so cool. I mean, that video alone, if you could just you know, show that. Remember the quote at the beginning with Arthur C. Clarke. Imagine a few generations before being able to see that. So, well, now we're at 1993. We've put Hubble up into space, this amazing $10 billion space telescope, and well, it doesn't work very well. And luckily, fortunately, Hubble was designed to be serviceable and update its technology with new instruments. And that's exactly what they had to do. It was a little embarrassing for NASA, but they did it. We're able to replace a lot of the parts inside and bring back, you know, a library of space history. Taught us so much more about the universe that we live in, exoplanets, stars, even more detail about objects like Uranus and Neptune in our own solar system. Just a fantastic achievement. James Webb Space Telescope is the next generation of I guess, a telescope that is not on Earth. James Webb is a little bit different than Hubble, where James Webb orbits the sun. It's not serviceable. So this is scheduled to launch in March of next year. Another $10 billion project, but it will be sent up into space. It will unfold its different parts and begin its science. It is 100 times more powerful than Hubble. So what this has the capability to bring back will be the next generation of textbooks for kids. We've got a couple really cool things happening this month. This asteroid you see here is called Bennu, and Bennu is considered a near-Earth asteroid. A little too close for comfort. Don't worry, it's not going to get too close for another couple hundred years. But this was selected as a sampling mission by the OSIRIS-REx spacecraft. We were able to watch this launch live at Kennedy Space Center. Really cool day. Bill Nye was there and all sorts of celebrities. It was pretty cool to watch this go up. It took about 2 years to get to the asteroid. It's a sampling mission, so OSIRIS-REx is going to kind of tag the asteroid, pull off some of the regolith from the surface, and bring it back to Earth for us to study. This will be the first time in history that we've done this, that NASA has done this. JAXA has actually done it twice already, so we're catching up to them. But the primary sample site is called Nightingale. You can see that in the upper left there. And the backup site selected is Osprey. And what's going to happen is as OSIRIS-REx orbits this asteroid, it's going to set up its alignment in such a way where it can tag the surface of the asteroid, that primary site. And it's got a really cool feature on it called the TAGSAM arm. And what this does is it pumps nitrogen, kind of funnels it through the arm, pumps up the regolith, kind of sucks it up like a vacuum in a sense, and stores it inside the TAGSAM arm. And that arm, that plate that you see will be what comes back to Earth, and it's scheduled to land in the Utah desert in 2023. Well, now that takes us kind of to what's happening in the future. May 27th, 2020, got a pretty monumental launch. Derek, how many launches have you been to?
Geez, oh man,
You can't count that high, right?
I can't count that high.
I mean, you grew up here in Florida.
I
You've been
did.
watching
I
rockets
remember.
go up since you were a
Yeah.
little tot, right?
Well, I have well, I used to have home video my dad took back in 1989 of watching one of the shuttle missions over off of Route 1 in Titusville. So yeah, I've definitely seen my fair share. One of my favorite launches was a Discovery launch, a space shuttle launch from the Causeway in Kennedy Space Center, was on my birthday. So that was one
Oh,
of my
very cool.
top 5 birthday presents I've received in my life so far. But yeah, definitely have seen quite a bit of launches, that's for sure.
Well, put this one on your calendar. If you're a local Florida native, we still don't know yet if they're going to, right now, what they're stating, both NASA and SpaceX, is stay in your home, watch it from home. Chances are probably very slim that you're going to see, if we were not in this quarantine situation, if we were not in the pandemic that we're in right now, man, the roads would be lined with millions, well, maybe not millions, but thousands and thousands of people to watch this launch. It's significant for 2 reasons. One, it'll be the first time since 2011 that American astronauts are launching from American soil. So that's a pretty big deal. We haven't been able to watch an American astronaut leave for almost a decade. But 2 is, previous to all that we've been through over the past 80 years, all spaceflight has been done by a government entity, NASA. This will be the first time in history that astronauts will launch up to the International Space Station on a commercial spacecraft. Now, they're partnered with NASA. NASA is very involved in this, don't get me wrong, but this is truly SpaceX's project. And Doug Hurley, Bob Behnken, they will be the first to fly on Demo 2. They're essentially going to launch up to the space station, dock, return home safely, and then prepare for Demo 3. Demo 3 is two different astronauts will fly that. And then once Demo 3 shows that everything is thumbs up and good to go, then we will probably see regular flights by SpaceX. And Boeing's still in the running. Boeing had a setback recently with their software, but I'm pretty confident Boeing will get their stuff together and will be very close behind. So mark this date on your calendar. Even if you have to watch it from your bedroom window or your front yard, it's just pretty historic. I talked about Perseverance. This is the next generation rover that it's not really replacing Curiosity. Curiosity's still going strong, but this has got the latest and greatest scientific tools on board. There was an announcement today that one of the tools got a name. What did they name it? Ingenuity. Ingenuity is the name of a drone helicopter that will be able to detach itself from Perseverance, survey the Jezero crater. And by the way, this Jezero crater has very, very, very good potential to find some really cool things. And it'll be able to survey that crater. We're talking about an ancient lake bed here, essentially. So, where there was water, there was probably life. And so Perseverance will be taking about 31 different soil samples from Mars that will actually be set aside and picked up at a later date to be brought back to Earth and studied further. So again, another pretty cool launch, July 17th, 2020. I'm hoping that we can watch this one from, as close as we can to Cape Canaveral. And then that takes us to going back to the moon. If you've heard of the Artemis program, well, we talked about Apollo quite a bit. Well, Artemis is Apollo's twin sister, and this is the next generation moon landings. We have the SLS, which is the Space Launch System. This is the rocket that has been built. It's been manufactured. It's done. It's going through testing right now. That testing has been set back a little bit because of the COVID-19 issues and things of that nature, but it's still moving forward. In the upper right, you see the Orion crew capsule. This will hold the astronauts, taking them to the moon. And again, those water deposits on the moon are really was our inspiration to go back. There was a pretty big announcement today. I had to throw this slide in at the last minute, but 3 companies were selected by NASA to build landers for this moon mission. So you would have the SLS, which is the rocket that would get us up into space. You have the Orion crew capsule that would take the astronauts to the moon. One of these 3 companies are going to build the lander that puts astronauts' boots back on the moon. Dianetics submitted their design to NASA. NASA liked it enough to put them down as the top 3. SpaceX, well, geez, they seem to be doing everything right lately. This was their proposal, and they were selected also with their Starship spacecraft to be able to land astronauts on the moon. And then the big boys, this is the national team. This is an up-and-comer in the game, Blue Origin, which is owned by Jeff Bezos of Amazon, Lockheed Martin, and Northrop Grumman. So a lot of big players and Draper. So this was just announced today. This is hot off the press, but these 3 companies are working to get this going. Now, the way Artemis is scheduled to work is in 2021. Again, this was all pre-COVID-19, so we'll see if this changes. It probably will. But 2021, we would send the SLS up into space, deliver Orion around the moon, and back to Earth safely, uncrewed, just the rocket and the spacecraft. 2023 would be a crewed mission, same process, launch, whip around the moon, come home with astronauts on board safely, and then 2024 would be the scheduled first landing back on the moon. So one of the concepts of this was called the Lunar Gateway, where they were going to build a kind of like an International Space Station, a smaller version of that would stay in orbit around the moon. And what would happen is, as astronauts left Earth, they would dock with the Gateway, and they would take service missions down to the moon to do their science, harvest materials, things of that nature, and then travel back up to the Gateway. They could always use that Gateway also as a fueling station to then go on to, I don't know, Jupiter, go to Mars, wherever you wanted to go. So we'll see where that goes. Derek, you did an amazing talk at Nerd Night a couple weeks ago where you talked about the future of spaceflight. And you talked about some really cool next generation propulsion. New Horizons is moving pretty fast. That went past Pluto in 2015. It's going about 36,000 miles per hour. But I mean, our nearest star, Proxima Centauri, is 4 light years away. That's 24 trillion miles. So until we come up with more sophisticated propulsion, we are really far off from leaving our solar system. You've got all sorts of new types of plasma expelled engines that we're working on. We've got the Bussard ramjet, which pulls the hydrogen, like you said, out of space and potentially could get you somewhere near light speed. Even have small CubeSats that can be propelled very quickly through space by lasers on Earth. But talk a little bit about what you found about how difficult it's going to be for us to really get to the point where we can even talk about leaving our solar system.
Yes, of course. The biggest issue with space flight is space itself, relativity. Essentially, Albert Einstein figured out that essentially the fastest thing that an object in three-dimensional space can travel is the speed of light. At that point, you're essentially pure energy, and obviously, you can't be other than matter or energy. So obviously, going even a fraction at the speed of light, you have cosmological issues with that. For example, if you were to travel to a planet, let's say you discover an exoplanet that is habitable over 100 light years away, if you were to travel near the speed of light to that destination, um, time is relative to you. So it may seem like a few years for you, 100 years would have passed on Earth. So if you were to say, "Oh man, I forgot to get my Nintendo Switch because I left it at Earth," and head back to Earth, 200 years would have passed for you traveling near the speed of light. And so, really, when we go beyond our solar system's easy. Solar system is, only a few billion miles, and most of the objects we want to visit, anyways, are only a few billion miles. So, going to around the solar system is pretty simple. But going to other worlds beyond our solar system is going to be challenging. And those are going to be one-way streets. Now, one of the options that you could potentially cheat space travel, or seriously, the speed of light, is by warping space around you using severe, very, very intense gravity fields that warp space-time so much that space itself gets compacted greatly, and you basically can go from one point to the next. And probably the closest thing to show example of that is the series Dune talks about folding space, basically taking space and compacting it to a point where 2 points meet each other. And essentially, that's really the only truly hackable way of traveling from one place to the other in the way that they see in movies and shows like Star Trek, where you can jump and from one point to the next and go against the law of, the theory of special relativity. So unfortunately, we do have some limitations. And most likely, the justification of going to a world beyond our solar system is going to be basically that the Earth is unsustainable. We eventually have to leave Earth, and we have to leave it behind and find a new home. So or there might be the possibility that we find life on another planet far, far away, and we want to go there and we want to interact with those individuals. But really, interstellar space travel is not like what you see in Star Wars. It's not like what you see in even Star Trek. It's much more difficult, and so this is something where I know Justin shares the same sympathy as I do about how all of this stuff that we talked about with human space flight, with traveling to other worlds, how it reminds us how beautiful and amazing our planet is. And Justin, you talked about Voyager 1 and Voyager 2, and remember Carl Sagan said he looked back at Earth, right? Wasn't there the pale blue, it wasn't the pale blue dot, that little tiny dot of Earth. And what was some of the things that he said in that when he saw those images for the first time? I think it was Neptune's orbit, near Neptune's orbit. They took a picture and they showed this little tiny speck of light, which was our planet far, far away.
Yeah, it is. It's a longer quote, but essentially what he talks about is how our Earth is just a. I just got to read it. I'm going to read it, Derek.
Okay.
Ready?
Yeah, go for it.
Look again at that dot. That's here. That's home. That's us. On it is everyone you love, everyone you know, everyone you ever heard of. Every human being who ever was lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every supreme leader, Every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam.
I mean, you can't get more poetic than that, right?
He was good.
And it just reminds us that, while we go out and explore the universe, we have to keep in mind that really, we go there as explorers, but really there is no place like home. And I think and every astronaut that has been up in space, we had Nicole Stott, which is an astronaut that lives locally here in Florida. She remembers her time, and when she was up in space, she would say that, it really gave you appreciation for planet Earth. There's very few astronauts that have gone into space that didn't come back as environmentalists for that reason.
Yeah, and the space program has brought us so much that has made our lives better. You look at the Apollo program, it was expensive. I mentioned that price tag of $25 billion, but there were multiple studies done, economic studies on this, that showed that for every dollar spent, $14 came back into the economy. So Apollo paid for itself 14 times over and brought us amazing things that you wouldn't even think about, like the smoke alarms in your house, the fire retardant. Oh yeah, that thing. So, the federal budget is $4.7 trillion. The NASA budget is $22 billion. That sounds like a big number, right? And it is, it's a big number. But $22 billion is less than 0.5% of our federal budget. And so if you take that number of NASA's budget and you divide it by all the taxpayers, you know what that comes out to about a week? Is a cup of coffee. So think about that, and you have the power to help motivate politicians and whomever that's following our footsteps, moving forward, becoming a more spacefaring society is in everyone's best interest. And it is expensive, and there's a lot of social issues that we still have to combat, welfare issues and things like that. But again, less than 0.5% of our budget goes to putting things like this and making things like this happen. So kind of finish with this quote, that nothing is so dangerous to the progress of the human mind than to assume that our views of science are ultimate, that there are no mysteries in nature, that our triumphs are complete, and that there are no new worlds to conquer. So I hope everyone enjoyed the show. I hope you learned some stuff, got a little bit excited about where we're going next. And I guess we can throw it out to any questions if we have any. Or
Yeah, so at this point, if anybody has any questions, I'm monitoring the Facebook chat. And for those that are watching, later on in YouTube, if you have any questions, be sure to leave a comment in the YouTube comment page, and we'll do our best to answer those questions for you. So if anybody has any questions, this is your chance to ask me or Justin any questions on that. So, and while we're waiting for questions, I want to talk about tomorrow night, because we have a very exciting program. Brendan Byrne is going to be joining us. He is the space reporter for WMFE. This is a local Orlando-based NPR radio station, and he hosts the show Are We There Yet?, which explores kind of our adventures in trying to get to Mars and beyond. And what a great way to talk about space exploration, and also to chat with a local space reporter that focuses quite a bit of his career on that. And we decided to play fun with it, because Brendan is also a very big interest. He has a very big interest in the difficulties of basic things in space. So, Justin, what is the title of our Star Party tomorrow, or at least part one of our Star Party tomorrow?
what would we name it? We said talking number 2 with Brendan Byrne. Talking
Right.
number 2.
Yeah, And that's then
Get your toilet paper ready.
essentially, yeah. So we're going to be talking about, things like going to the bathroom in space may seem like an easy thing, but it's actually not. It's actually quite difficult. And what do we do with the doo-doo, basically, in space? And after the second part, or excuse me, after the first part of our star party starting at 8 p.m. tomorrow, by the way, we are going to be doing a program that is going to be exciting because it's the first time we've had in weeks. We're going to have clear skies, so we're going to go out with a bang. We're going to go with the star party as long as we can because we're going to take advantage of these clear, nice skies tomorrow night. So for those that are interested and excited about astronomy and want to go out and do some observing, this is tomorrow. Tomorrow is the night to get out. We're going to have Frank Kane, who is our telescope operator and member of the Center for Astronomical Society. Has been graciously helping us with hosting these, co-hosting these star parties, and you do not want to miss it. And for those that are watching on YouTube, we'll be uploading that star party on our YouTube page, so be sure to also visit that as well under our virtual star party playlist. So lots of different opportunities to continue on. And for those that are watching on Facebook, all of our Facebook Lives are, of course, on Facebook Live at the time. So tomorrow it's going to start at 8 p.m. And then we'll be doing our second half of the star party starting at 9. And who knows how long we go. We may go all the way through the night because why not? This is our clear night. We're going to go off with a bang on that one. Now, I want to tell you about next week's virtual public show. One of the topics that is brought up a lot of times is astrology versus astronomy. And we have a special guest.
Wait, you're saying they're not the same?
They are not the same. Same thing as cosmetology and cosmology. Those are not the same thing. So we have a guest from the Williamsville Space Lab up in New York. Her name is Jackie Bowman, and she's going to be joining us next week for our public show that will be exploring all about astrology versus astronomy and called the 13th Sign. It's one of our planetarium programs that we offer, and she's going to be joining us as our special guest for next week. So that's Thursday at 7 p.m. But anyways, let's see if we have any questions from the Peanut Gallery here on Facebook. It doesn't look like we have any questions. Justin, you did such a great job.
That means I was thorough, I guess. Yeah.
So thank you again, Justin, for hosting. I've been proud of you for doing that. Great work on that presentation. Justin's kind of our local expert when it comes to space exploration. As you can see, he hates space exploration. His back, the back area, I don't know why he has all that stuff back there. I mean, he doesn't like it at all. But again, thank you, Justin. And again, we hope to see you all tomorrow night for our virtual star party. And with that, I'm going to go ahead and stop the recording for YouTube. So if you're on YouTube, we'll see you next time. And